Hi everybody, Dr. Pingle here. In this part of the lesson we're going to talk about installing and using LAStools. So LAStools are a really lightweight and powerful tool set that you can use with ArcGIS by themselves on the command line via attached graphical user interfaces or GUIs. It's just a really handy way of processing and manipulating LiDAR data. So we're going to get a chance to use some of that today. So if you just Google LAStools, you'll get run across this page. So it looks something like this. The company that distributes this is called Rapid Lasso, and the LAS of the first part of Lasso is obviously related to LiDAR data. So to download this stuff, it's pretty easy to do. We've got to download LAStools here. I'm just going to create a temporary directory here that we'll work with for this part of the lesson. So we'll just make it temp3. So if I download this, it's a relatively small download. So this is about 55 megabytes. I'm going to pause the video while that comes in. If you've got a good internet connection, this shouldn't take more than 30 seconds or so to download. Okay, that program has come in, so I'm just going to browse into the directory here, right-click, and unzip it. So I use 7-zip, which is a pretty powerful zipper and unzipper. But if you're just using a built-in one on Windows, you can do extract all. Now I should mention that LAStools only runs on Windows, so you'll need to make sure that you're using that. But you're probably used to that already since ArcGIS only runs on Windows. There aren't a lot of files in here, so this shouldn't take too long to unzip, so we'll just kind of wait while this gets through it. So if we double-click into this directory, we get something that looks like this. Now, we have a lot of, it's a pretty simple directory structure. We've got the data sources, we've got binaries, which is what we're going to use. We've got example batch scripts, so you can kind of look through some of these and see how you might do more advanced things by chaining some of these commands together. Classifying LiDAR, for instance, is a combination of several tools using a ground finder, calculating height, and then running a classifier on top of that. All just sort of put together by a text file called a batch file. What we're going to do, though, we've actually got some sample data in here if you're interested. We've got some data from Zurich. I saw some data from France in here. What I want to do is talk about how we run some of these tools. So if we go into the bin directory, which is short for binary, we have a number of different things. So we're going to use LASinfo to start with. But before we do that, we're going to need to download and convert some data. So we're going to go back here, and the familiar interface for the Virginia LiDAR distribution network. We've already downloaded, you may have already downloaded a few of these. So this is the Virginia Tech campus. We used these 6 tiles that are sort of the campus and a little bit of the adjoining town. I want to download these 3 tiles as well. So if you click on one of these, we can download all of these files, and you can just dump them into this directory for now. Or wherever you want to put them. So these are going to come in as ZLAS files. They're all relatively small, so they shouldn't take you too long to download. So we'll just kind of click through some of these here. Okay, so that's all 9. It looks like we've got a couple of seconds to wait until those come in. But if we open the directory that we downloaded them to, which is right here. You can see that they're almost all the way in, and we're talking about 5 to 6 megabytes per file, so not very much. As we talked about earlier, these come in as ZLAS files, which is Esri's zipped LiDAR data format. LAStools actually has its own zipped LiDAR format called LAZ, and if you look in the data directory here, you'll see that we've got some of these files are coming in as LAZ files because they are compressed and much, much, much smaller than they would ordinarily be. What I want to do is use one of the tools that gets distributed with LAStools called LASLiberate to extract those files. So there's a command line tool that we could use to do that. I'm going to hold off on that for just a second and use the GUI that comes with it. So we've got two pieces here. We've got an open file. So we need to go into our directory where we just saved those files. And we can select one of these. And we can extract it to either an LAZ or an LAS. So an LAS is going to be that open ASPRS format, the universal standard for LiDAR data. But we could also extract it to this LAZ file, which Cloud Compare can read, many programs can read. But we're going to stick to LAS for now. So we'll hit liberate, and that's going to extract that file. And if we go back, excuse me, if we go back to our Blacksburg directory, you can see that now we have an LAS file, which is about 7 times larger than the input file. So we can go through and we could kind of do those one at a time, which would be fine. A faster way to do that would be to use the command line tool, which can unzip all of them all at once. But because I want to keep things simple and kind of keep things moving, I'm just going to go ahead and do these by hand. There aren't all that many, but if there were too many more than this, I would certainly not be doing this one at a time. I would be automating this. So this program, LAS Liberator, is essentially the same version. It's doing exactly the same thing as we've done before. I've got to look carefully to make sure we're not skipping one here. So that's 12. This is the danger of doing things by hand, by the way, is you've got to keep much closer attention to what you're doing. Easy to miss one doing it this way. So this LAS Liberator is doing exactly the same thing as the Esri distributed tool that we've used in the previous lab, just a different way around. One of the nice things about the Esri tool is that the GUI actually does support batch processing right from the start. You can pick a directory rather than an individual file, and so that's pretty handy. So we're just going to do a quick count here and make sure we got them all. That looks like we've got 8 items, so we're missing one. Let's see. Which one are we missing? 22, 23, 32, 11, 12, 13, 14. So this is the one that we missed. That's the one we missed. Okay, so all of those files have been unzipped, and we can now use them. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, now we can load these straight into Cloud Compare. If you've got Cloud Compare already installed, you may be able to just right-click on or double-click on these and open them up. You get the same kind of thing as you've seen before. And it looks something like this, and we can do what we just did on the last one, which is color this by height value. So remember that Cloud Compare uses basically attributes that get attached to the points called scalar fields. So we're going to export our z-coordinate as a scalar field, which lets us color by that. So there's one of our 9 tiles, and we've seen this before. Now, one of the things that you might be interested in is the metadata here. So we're not getting a ton of metadata. We've got information about how many points there are. So you can look through the list and see that we've got 1.2 million points. But we're not getting much more information than that. And in fact, there's a pile of information in here that we might be interested in. So we're going to go into LAStools and use one of the binary files called LASinfo to do some of this stuff. So if we double click on LASinfo, we get a screen that comes up that looks something like this. And we can browse. 1 dot means the current directory. 2 dots means you're going up a directory. So we're kind of moving up a directory maybe a couple times until we find our Blacksburg data. We can open up one of these files, and it looks something like this. What we have is some information about what we are looking at. So I've maximized. Sorry, adjusting the mic there. I've maximized the screen here. We have this information. What are we getting out of this? Well, some really basic information. We have the LAS version. So the LiDAR point clouds are recorded in different versions, different specifications. So we know that this is in a version 1.2. We know when the data was created. So it was created on day 147 of 2010. This is a Julian date. So if you Google Julian date, you can find a couple of different tables or converters that will tell you when this is. So this happens to be, I think, in April. We have a couple of other pieces of information here. We've got a number of points. So this particular LiDAR file has 1.2 and change million points in it. We get some information about the bounding box, X, Y, and Z. And there's actually a lot more information in here, but to look at that, you're going to need to run the tool. So it kind of picks through some of that data and displays a little bit of that data over here on the left. But if you want to look at all of it, what you need to do is run the tool. Now, LASinfo is one of the simplest tools that comes with LAStools, and so most of the time when I use this, I do it from the command line. So I'll show you in a second how to do that. But what we're going to do is we're going to check the output options over here on the right. Probably if you've just loaded it up, it's set to this one. And you're going to select this one. So *_info.txt. The asterisk is what's called a wildcard. So it's going to take whatever the input file name is. So that's that. And it's going to add on this _info.txt, and it's going to populate that file with information, metadata about this particular file. So this is a little bit different than using things, and this is frankly a little bit kind of a clunky way of doing it. As I said, I usually use the command line, and that's a little bit faster. We're going to run this tool here. You get a window that pops up that's telling you exactly what's going on. So it's running LAStool. -I means the next thing is an input. So this is the input. This is the LiDAR file that we're reading. And then these are some tags saying, how do we want to output this stuff? ODX means output it in the same directory you got it from. And then we're outputting a text file. So we're going to hit start. The tool runs immediately, so it's already done. And if we go back to the LiDAR directory where we saved all of our things, we'll have this file that's the same thing as the input, _info.txt. And this says where the file came from, and we're getting a look at the inspection. So we're getting a look at the header data. So here's the day it was created. We've got information about the number of points, so there's that number again. Number of points by return, so this is first return right here, so most of our data are coming back as first return data. This tells us the precision that's in our data set, so in this case this precision is being distributed as 0.01. To know what that measurement is, you need to know what the projection is, or the coordinate system. And so we'll have to look down a little bit and see if we can figure that out. So here we have some information. This is North American datum of 1983, State Plain, Virginia South. We've got a FIPS code 4502, and it's in feet. This is the vertical datum, NAVD88, and that's also in feet. So it's important to know that the coordinates, we've got our coordinate system, we've got our projection. And then we have our units. So this particular LiDAR data is being distributed as feet, which is not uncommon in the United States. It's a little bit more common to see this stuff distributed as UTM. So most of those would be meters. We also get some information about maybe the kind of software that was used to generate this. In this case, it's LiDAR 1 tiled, which is probably some custom script. We've got more information down here at the bottom about sort of a histogram-like representation of what's going on here. We've got 108,000 points which are unclassified. We've got about 500,000 points that are ground, some noise, and then some overlap. So that's a brief introduction to how you can use LASinfo. Let's take a quick look at how we can do this from the command line. So the command line is opened in Windows by right-clicking and hitting Run and typing CMD for command. So this opens up a window that you can use. You can move around in this. If you've used Windows before, you may know some of these commands. dir is a directory command, and it'll tell you what's in here. ls is Unix for the list directory, and does the same thing, but it doesn't work on Windows. You can change directory with the cd command. So cd 2 dots means go up a directory. You can move into directories, so you can say things like cd, we could do a directory list here, we could say cd temp to move into temp 3, for instance. So now we're in temp 3. We can do a directory here. And so you can see we're kind of moving into the same space as we were here. Now your LAStools binary directory is where you run all of these from. So if you click on your file bar up here, you can hit Control-C to copy that path. And you can actually type in cd and then paste. So this is Control-V to paste. And then you move directly right there. Now what that lets you do is it lets you do things like, say, LASview or LASinfo. Once you're in this directory, you can run anything that's in it. So you could say LASview -i for input file. And then you could put down the path to whatever it is that you're interested in looking at. So if we're interested in this file, we could paste that in here, hit \, and then type in LAS SO3 9620 22. And once you get far enough in that this is a unique file name, you can actually hit the tab key, and that auto-completes everything else. If you have files that kind of have the same pattern, like this one does, we've got a .las and a .lax, you'll have to specify that if you want. But this was the original file that we did up here, so this is the info file for it. We're going to hit Enter in our command window. Oops, that was LASview, I'm sorry. We're going to hit up arrow to get back to that, and we'll type in LASinfo and hit Enter. So what you're seeing very quickly as that scrolls by is all of the information about that file. So this is exactly what we just saw in the text file, just spit out to the console. And this is how I usually work with this data. It makes life a little bit easier. I'm usually just sort of inspecting something on the fly and then moving on. Now the last thing to note is that if you are using this stuff, you are either going to need to put a full path name to where your LiDAR tool is, or you're going to need to put a full path name to where your data is. And to get around that, what I usually do is declare a path. So I will do that by setting this in Windows. You can go into Advanced System Settings. You've got an Environment Variables screen right here. And in this variable screen, you've got paths that you can edit. So if I look at the paths, I can edit this. And what I have here is LAStools binary. So I've got that in my path. If you don't have that in there, you can hit New. And then if you want to paste a thing in here, you can go to where you saved your files, or wherever you're going to keep them, more likely. So in this case, I downloaded these to temp. I've got my binary directory. So I would copy this and paste it into this new area right here. I've already got that, and you can see that I store my LAStools in program files, LAStool binaries, because I'm going to need it pretty often. So I don't keep this stuff in a temp directory. But that's a little bit more than you need to know. That part's not required for the notebook. But if you are interested in how to kind of use LAStools more routinely, that would be my recommendation, to declare a path, or to add it to your path rather, and then you can use it from anywhere. And so because I have it in my path, what that lets me do is from any directory that I'm in, I can run tools. So I can say LASinfo, and it's going to try to run that tool. And the nice thing about that then is that if I go into Blacksburg, where I have my lidar data, I can say LASinfo, LAS03 9621 42. Hit tab to autocomplete. Oops, must have made a spelling error here. That does happen. SO3 9621. There we go, autocomplete. And I get that same information. So by having LAStools in your path, you can run those LAStools from anywhere. Okay, that's it for part one. Thanks for listening, and stay tuned for the next lesson.